This is video 1 of a series about building trading systems, and in this one we cover trading system architecture and the general overview of what we're going to build. You're here obviously because you want to build a trading system, either because you're taking one of my Duke FinTech courses or you're following along on the internet. In the first case, I want to say congratulations. You certainly made a great choice by choosing Duke, and arguably an even better one by taking my course. This and other videos are going to be your guides for that course because it goes over the software architecture, the tools, the systems that we're going to be using throughout the courses. Some of these are Duke-only resources that you're going to need your NetID for, things like the Duke VCM that we'll be using. And if you're following on the internet, I want to say welcome. The reason that I've put these videos out in public internet is mostly because of you. I want to hear your feedback. I want to disseminate this knowledge. I want to keep track of things that are changing out in industry and in software stacks, and try to stay as up to date as I can. So your feedback is quite welcome. These videos can still help you, even though in our architecture we do use some things that are only available for at Duke. And the reason is because there's a lot of publicly available substitutes for most of what we're using. So I hope that you can still get some utility out of this. I certainly want to know if something happens to work particularly well for you. And I thought I might as well point out that if you're interested in building automated trading systems, you might want to check out the Duke FinTech Master of Engineering program, and I've got the link right there. So when we're doing this, we want to build a live trading app that actually connects to order execution systems and can listen to market data and actually make trading orders in a disciplined and intelligent way. Along with that are a few IT requirements, a few requirements of just the system. And when I was starting to build this structure to use for this course, I sort of wrote down what those were. And we're going to start with that, because a live trading app obviously needs to be stays on and running all the time. You can build a script or a system that runs on your laptop and does everything that you need it to do, but it depends on your laptop being turned on, charged, connected to the internet, and there's a lot of ifs then. So we want this to be on and running all the time. We want it to be able to safely reboot and restart in the event of a system failure, to be able to handle that kind of thing. And we would need to be able to communicate with it in some way to see how it's doing, to do manual order entry, to do manual operations like stopping a trading order, changing a parameter, and so on. So we need some way for this trading system to be active, and we're going to do that by making it accessible as an interactive website. And we're going to do this with SSL, which avoids warning messages in browsers, and it's going to improve your page rank on Google if you choose to have something like a public splash page. What I mean by that is everybody has seen this window at some point in time. It's what Google now gives to pretty much any website that doesn't use HTTPS. And we're going to need to be able to do that, and we're going to do that with Certbot, and that's going to be covered in this video series. Because you want to avoid this. The last thing you want is to build a trading system that you actually want to get some actual investors interested in, and anything that scares them away is obviously not to your best interest. So we want to get away from this and stick with SSL. We want to make it as easy as possible to work with the understanding that systems, data structures going into a system happen all the time. There's edge cases, things you didn't think of. We need this thing to be easy to work with, and easy to work with in a group. Even more important, right? Because if you're taking some of my courses, you're not the only one operating and doing development work on a trading system at a given time. So we need to kind of coordinate that. We're using GitHub for that. We need to be able to communicate with external trading systems to query account information, like what's your account balance. We need to be able to issue a market order, limit order, get current market price, and so on. Just need to be able to connect with a brokerage system out there on the internet. And we also need to be able to have your website needs to have selective access, right? If you have a client, then they should be able to view only information pertaining to their account. The public should really only be able to view not much more than the splash page, which says who you are, what you're doing, if you even choose to make one, right? Whereas you and your team need to have full access to the entire site. We need some way to be able to handle that. There's going to be proprietary data. There's going to be your trading strategy, which you may or may not want to be publicly known. And you need some ability to do password protection. So we're going to handle that. And lastly, for Duke students, when I say free here, I mean free as in no additional cost, right? Because when you pay to go to school, it's obviously there's a exchange there. So it's more like the services we're using aren't exactly free. It's more like you've already paid for it, right? But I want to be able to have no additional costs for Duke students, and with the option of being able to run and control your own hosting. Okay, so you could, in theory, run your entire trading system and make it accessible just by building a decent gaming PC, setting it up as a server, and running that, and that will actually get you surprisingly far along the way. You're just going to need a solid internet connection, which somewhere just plug your computer into somewhere you can trust. But I want you to be able to do that even if you choose not to, and use an external company like Heroku or AWS for your server needs. And finally, I want to provide a really smooth workflow for updating and viewing and troubleshooting in a team environment with multiple collaborators, and getting this app up and running and the best it can be. Because the worst thing that can happen when a big development project is, say you fix a problem but it breaks something else, and then you fix that something else but it breaks the first thing that you tried to work on, and you wind up chasing your tail for weeks. That can happen, and it's really irritating. So I want to make the architecture itself conducive to good workflow practices, and that's kind of what have striven to do here. So let's talk about the system architecture of how we're going to accomplish these objectives here. And it all starts with a server, and we're going to be using Windows. And a server can be thought of as an empty blue box, which represents a computer that's always turned on and always connected to the internet. All right, you have admin access to the server, and you have the ability to remote desktop in and treat it as though it's a local computer. All right. You're going to need to get a server. So, because you have to run your app on something. You do have a few options. One is to just do, as I mentioned earlier, which is just buy a computer, connect it to the internet, configure it, and roll, use it. You can certainly do that. Advantages, disadvantages, of course. You're gonna have to power it. You're gonna have to keep it turned on all the time. Your internet connection is gonna have to be stable, and so forth. But using this architecture, you could actually do that. You can use a service like AWS, Heroku, DigitalOcean, and so on. There's about 1 million providers out there that will offer you a remote Windows server as a service, and all you have to do is just Google it and find the right one for you. But if you're with a university or an organization, a lot of companies and universities these days offer this for free as a service through the Office of Information Technology. At Duke, it's OIT. And we're in the course, we're going to be using that option. I caution those who want to do this to watch out for tech transfer obligations. This is anybody who's not in my courses. If you're in my course and you want to talk about this, let me know. I'll be mentioning that in class. I'm not particularly worried about that in this video. But for those of you out on the wider internet, be aware that pretty much any organization that's big enough and established enough to offer a virtual private server as a service is going to also have some kind of tech transfer obligation, which assigns to your company or organization rights to any IP, intellectual property, that you, such as a trading system, that you develop using their resources, such as the VPN. Okay, so just this might not be the best way to develop this. Is if you're working at a company and developing a trading program on the side, I would probably say don't use this. But I'm not a lawyer, and I just think you should be really sure to understand your tech transfer obligations before you start using option number 3. In my course, we're going to use it because it's well established and part of coursework and part of homework. But the point is, get yourself a server, set it up, admin rights, reliably connect to the internet, and accessible remotely. And Duke students, we're going to use VCM. And at the end of this video, I'm going to be showing you how to set that up. All right. So I'm going to assume now that you have your beautiful blue box set up and running, accessible, everything that you need. And on that box, you're going to have a trading app. It's right there. A trading app, and any app is same as any computer system, really, which is nothing but files and a bunch of if-thens. I've got PC on there for PyCharm because we're going to be using Python to write these apps. We're going to be using Dash. And the IDE that we'll be making the most use of is PyCharm. And this folder, which has your apps in it, you want it to run on your server in that blue box. And what you really want is to be accessible to your clients. Here I pulled a picture of Jamie Dimon looking happy because you're a massively better trader than he is, and you're making tons of money because he's your client. And so let's say you have a client, and then there on the below that is you and your team. All right. And as I said earlier, your clients only have access. It's limited to certain pages, whereas for you and your team, you need to be able to view everything. All right. So what you want is for the entities over there on the right to be able to access and work with your trading app in an appropriate way. So you need to serve it and you need to run it, right, through the internet. All right. So how we're going to do that is with a two-step process involving WSGI, a web server gateway interface. We're going to be using Waitress that runs the Python app that's in your trading app folder. And that's going to serve that Python app on a local directory that's local on that server. All right. And we're going to configure a web server. We're using Nginx. The web server is going to listen for the app on a dedicated port to the app that's being served in Waitress. And Nginx is going to make intelligent decisions about serving that app to the wider internet. It's going to handle Nginx is going to handle talking to GitHub. Nginx is going to handling client authentication, and it's going to handle the actual serving of your system. Okay. So, if you take a look here, I'm going to go back a slide and just take a look at this. This is looking pretty good, but it's static, right? I haven't really shown you here. There's not really a good way to work in what you're going to. Let's say you wanted to update this thing, all right? You would have to remote desktop into that server and change it, open up your trading app, change the code, and or maybe push something to Git, and then open up your trading app and do a pull and update your updated code that way, and then restart everything so that the whole system is running now your updated app, right, to serve to everybody on the right, which is irritating and pretty lame. So what we're going to do is talk about workflow a little bit, because apps are complex, stuff happens, things change over time, and so on. And look, you get into this and you bought a data subscription from a data vendor and set the whole thing up, assuming that, I don't know, historical stock prices are coming in as in a JSON structure or XML structure. But one of your teammates finds a much better data vendor, so you switch to that data vendor, but they use XML, which is, conceptually similar, but you're gonna have to do some code changing, right? You don't want to do it the long way, which is log into the server, do all your changes, test it. There's gonna be downtime because you're gonna have to do this, I guess, overnight, and you're gonna have to document how you did that for your teammates and for the arguably a very important teammate whose name is your future self, right? You don't want to confuse that person. So just this simple thing can actually get very confusing the more complex an app is, and it gets worse the more people you have working on a project. Then there's edge cases. One of my favorite ones that can happen is this example comes from 2012. Hurricane Sandy, when Texas Instruments issued a dividend during a non-trading day because the market was shut down because of Hurricane Sandy. So there's no market price on that day. But if you have a system that does merges on dividends and stock prices, and then comes through that data frame to do something else, it might throw you an error, it might give you a wrong answer without telling you anything, which is way worse. Who knows, right? So you might need to jump in and fix something like that, because worst case you foul up null NA or something like that, and you have a big old crash. So, but we need that to be as painless as possible. And then you're always going to be wanting to add new code to this, change it around, and so on. So we need a good way to do that. The workflow is how we do that. All right, it's the disciplined process by which you and your team writes, updates, and tests an app. And as I was writing this, I threw this down there at the bottom because I kind of realized that, hey, in accounting, there's the saying that cash flow is more important than income, right? Which, and what's meant by that, which is if you're intelligent in how you manage your cash flow, how you manage your money, you are going to get richer over time. And then pretty much time is on your side. Even if you make a ton of income coming in, if you're silly about how you manage it, you're not going to get rich. So it's like in this way, the system, the accumulation is the workflow is actually more important than your trading system, right? Because you can develop some great trading system that you kind of threw together halfway and tossed up a couple of investors, and now you're like real deep into people depending on you and so on. And then it breaks and you can't figure out why, and your team's butting heads over each other trying to fix this thing, and you're gonna realize fast that workflow is more important than a good strategy, because a good strategy can fail at any time, right? Some black swan event can happen. We all know that that's not impossible anymore. But the positive side is, if you have a good workflow that's solid, good disturbance rejection, then you can pretty much trust that you're going to be successful. All you got to do is pour time and dedication into it and turn the crank. So it's a little bit of a uplifting little point. All right, back to system architecture. What I want you to be able to do, and what we're going to set up, is we're going to configure your GitHub account such that when you or your team push a change or a merge or whatever, and change the main branch on your GitHub repo, Git is going to send a payload to a dedicated endpoint on your server, on your blue box. All right, that little endpoint is going to then initiate a process that will do a pull request on your trading app, so that your trading app always stays up to date with the most recent version of what's on Git. All right, that means that you can be doing development work on your local computer, whatever, do some tests, run it, test it, looks good. You can push it to Git. Git will turn the crank and push it right back out over here to your server. And it also lends itself. In my course, I don't use test servers because there's a limit to how much to the complexity that you can cram into a semester. But if you want to do a test server, all you need to do is spin up 2 of these guys, right? And push the test server, have the test server watch, just create another branch called test branch, all right? And configure your test server to keep it up to date with that branch. And then if you push it, everything looks good, you just merge that into your main branch, and your main branch runs on your production server, right? It's not that many extra steps. But what it does is it gives you the ability to play with your app on local, fix it, get it looking good, push, and update on the internet. And this process is fast, like on the order of, when I do it, it's usually 1 or 2 minutes it takes to fully turn the crank and start serving the new version. So not too bad. All right. Now I want to talk about reference data, which I'm symbolizing by that little database icon right there sitting on the server. On our system, I'm going to put data in a folder right there on the desktop where it's obvious to any team member, to me, to the TA, whoever logs in to your desktop, it's going to be like right there. and it sits there for a few reasons. So I want to talk about what I mean by reference data, and that is reference data is data that does not change over time. Okay, so I mean not the temperature outside, which changes over time. All right, I mean not the current price of Exxon, which changes over time. However, the historical temperature does not change. The historical data, you only need to marry one. Marry. Historical data, you only need to measure once. The historical price of Exxon is fixed. As you in theory, you should only download that on your server one time. Now that's difficult to do in practice because things change, and as you get your system set up, you might wind up downloading the same data a couple times. But in theory, all historical price in your entire life, you should only download it once. Descriptive data is also reference data. Like if you have, for example, a really long-running classification, unsupervised learning classification program, all right? And what it does is it takes, I don't know, equities, and it looks at historical price, and it looks at parameters like what industry is this stock in, what are some numerical descriptors of the CEO, how's some data that you got by scraping quarterly reports and so on, and it comes up with a cluster, all right, and it takes, let's say this thing takes like 10 hours to run. Well, obviously you don't want to run that in your app, right? You want to run that like one time, and hopefully you only want to like update this every year or so, but you want to run something like this one time and then save it as reference data, and then your app just loads it, okay, when your app runs. And maybe it's a lookup key, like you have your a custom ID for a particular security to avoid confusion with using tickers, ISIN, QSIP, whatever. You want to have your own unique ID that your system uses to really reference exactly what a security is. Well, that's cool. You need to have, but somewhere on there, you need to have a key that has your security and a column of those, your ID with that security's name. Maybe some other things like ISIN, QSIP, whatever. But you need some kind of a map to it, right? That descriptive data, reference data. Username, password, permissions data, also reference data. And having it here makes it pretty easy for you to add new users, come in and change permissions, onboard new clients, new team members, and so on. But that's reference data that isn't necessarily financial, and so on. Probably there's tons of examples. But the bottom line is that reference data does not ever go in your GitHub repo. All right, it's often sensitive. It can break if you upload historical price data to your GitHub. Whoever sold you that data, your vendor, is probably going to come after you because that's like a major violation of your data agreement, right? Plus GitHub has a cap, right, of what, like 25 megabyte cap for any push that loads up to GitHub. So you can quickly exceed that with historical price data, and just for about 1 million reasons, keep your data on your server, not in your GitHub repo. Okay, so that's what my reference data is right there. Other thing you're going to need, obviously, is some kind of way to talk to your trading account. So you're going to need a trading account. In my course, I set you up with interactive brokers, and you get a paper trading account, which uses real-live streaming market data for equities, futures, options, bonds, currencies, pretty much everything, crypto now, and you can buy and sell and trade, and it'll just track what you did as though it were real. All right, so you can just track your imaginary balance and take everything on paper, which is why they call it a paper trading account. You need a way to talk to that thing, and how you talk to it is through IB Gateway, the execution system client, which runs on your server. And IB Gateway takes orders from Waitress and gives information to Waitress. Like if you want to query what the current price of something is, that's going to come from your brokerage, but you will send a request from your app running in Waitress to IB Gateway which will ask interactive brokers, give me the price or whatever it is you're asking for, and communicate back to Waitress, and your app will take that into account, right? But we need that two-way arrow to be set up to the markets, to your trading system, and we're going to be doing that with IB Gateway. Similarly, you're gonna want to scrape stuff off the internet. Stuff like U.S. Treasury data is really easy to scrape. Energy Information Agency, the EIA, has dropped super valuable information. I mean, this may be like one of the data sources that is free and very, very useful. All you need to do is just scrape the EIA's website every Wednesday when they do their update, and gain a ton of valuable data. So I'm just representing that with the cloudy internet that pretty much every single trading system architecture diagram I've ever seen in my life has a cloud in there somewhere. So what am I supposed to do, I guess? But it's a two-way communication because you send the request, pull it back, and so on. But you're going to need data from the internet, and that's what that means. And this system is starting to look pretty good, except for one thing that's missing, which is you need a way to control all this stuff. And what I said earlier about, like if Nginx, for whatever reason, errors out and crashes, you need a server to or you need something to restart that. All right, Nginx should always be running. Waitress should always be running. IB Gateway should always be running, and so on. How we're going to do that? We're going to use what's called a service manager, which has the task of keeping those guys up and running, as well as the task of seeing that they start and get up and running when you turn on the server or reboot it or something like that. We're going to use NSSM, the non-sucking service manager, because pretty much when the developers realized, as you might when you really kind of think of it, all you really want from a service manager is to not suck, right? You just want it kind of to go in the background, and you want your systems to kind of be there, and you don't ever really want to worry about the service manager. And I can say that from my experience, NSSM has worked pretty good. So we're going to be using that in the course. All right, so what I'm going to do now is I'm going to spin up a Windows VCM. And this is mostly for, this part is for Duke students. And you can probably turn this off at this point if you're coming in from the internet. But I'm going to spin up a VCM, and I'm going to turn it on. I'm going to do a few things, like deactivate the auto shutdown, do a test connection, and so on. And I'm going to connect to it with Cisco AnyConnect. So if you don't already have Cisco AnyConnect on your computer and you're a Duke student, I want you to install it. And you can do it by following that link. And if you're a Mac user, I'm going to need you to install Microsoft Remote Desktop, which you can pretty easily get from the Apple Store. And I think it's probably going to come up in another video, but if you're a Mac user and you don't already have it, you should probably already go ahead and install xTools, because that's a long install, and one way or another, you always wind up needing it. All right. So now I'm going to break out and do that, and let's get started with making a VCM. So over here, I don't think you can see this, but over here, I'm going to be going to VCM, the website that I showed you. So I followed that link to the Duke VCM, and I'm going to log in. And that's all I did off the screen. And here's what I see when I do that. Okay. I see here's some virtual machines that I already made, and looking pretty good. I'm going to make another one. All right, Windows 10. And if you're in my course, we're using Windows this semester. Has to be Windows. So I'm going to agree to the license. And at this point, it's going to spin itself up. And pretty much, I may need to wait, and I may need to edit this video and do a little bit of the old cooking channel magic where I fast forward it. but I'm going to try it and see just how quickly this thing actually starts up. While we're doing that, I want to talk about this automatic power downs business. I'm going to click that off because what we're doing is building a trading server that needs to be on all the time. So Duke does this to save energy, to be environmentally friendly, and to keep people from just automatically clicking that they want their server to be on all the time when really maybe they don't need it. We actually need it because, and it's asking me to explain why. And we're going to say this is a server running a continuous trading system for a course that must be accessible dependably, sure. And we're just going to click create. Boom, done. All right, good to go. So now I'm going to get a phone call. How about I turn that off? All right, done deal. So let's see here. Next, I'm going to open remote desktop. And in Microsoft, you just go to search and just type in remote desktop. And on Mac OS, it's like the same thing, just use Spotlight. Okay, here I'm going to open remote desktop, and this is what I see. Okay, little remote desktop connection. So I want to click on more options, and what I want to do is I want to make sure that my VM, my virtual server that I spun up here, I want to make sure it's working and turned on and accessible and so on. And I almost forgot. Before I do that, I'm gonna have to use Cisco AnyConnect, which is right here. If you downloaded Cisco AnyConnect, you did that by following the instructions on the link that I gave in the last slide. We're gonna connect to Duke's VPN, because if you don't do this step, you're not gonna be able to access your server. It's not gonna allow you in. So I want to connect to the VPN, which is at portal.duke.edu. I'm gonna click connect, and it's gonna ask me. I'm gonna type in my net ID, and it's gonna ask me for my password. And I'm going to go down here and type in my password where nobody can see that. So give me a second. All right, now it's asking me for my MFA option. That's my multi-factor authentication. And I've got my Duo push all set up. So it's asking you for your options. I want to use option 1, which is just the normal push. And I'm just going to hit it. 1. I typed in 1. You can't see it because it's protected, but I typed in 1, and I'm going to continue. And got my little beep up here. Let's open that guy. See? Click approve, and I'm in. Boom. So now, if I show my little box, look. So I'm nice and connected to Duke's VPN. This is as though I'm on Duke campus, but I'm not. I'm in the warehouse. So my warehouse. Let me see here. Now we just want to connect to this guy. We're gonna need. So what host are we connecting to? Well, we're connecting to this little guy that I just spun up. That host. So let's put him in, or her. Maybe not. Let's put right there, and computer. And what's my username? Well, I don't know. Let's go find out. Oh, look. It's VCM. Cool. So we're going to do VCM. And now all we need to do is connect. All right. Now, it tried to connect, but the VCM is asking me for another piece of authentication. It's asking me for my password. I'm going to click remember me because I like to save these little individual connections because I have bunch of different students, right? Sometimes I need to log into their servers. So I save these individual credentials and I give them names so I can just open up and log into somebody's server if I need to. As an instructor and a TA, that makes things way easier. but it wants to know what password I want. So I'm just going to go here and grab the password that it gave me right there. Let's grab that guy, copy, close, bonk. And let's just check to make sure nothing crazy happened. Looking pretty good. And click OK. We'll wait for it. And boom. So this might take a while. And it's okay, because what it's doing is you just created out of the ether. You just spun up a Windows computer out of nothing, which is pretty cool. But every time you do that to a brand new Windows computer, you have to go through that process of initialization and setting up and so on. So I'm going to let it do that. Probably going to go get a coffee. It takes, who knows, 5 minutes or so on. But I may or may not probably will speed this up, and I'll see you when it comes back. Okay, great. Looks like it's back up. So we have some new software. And then you probably want to let this run. It's taking care of your mapping. That's a script that OIT has your computer do, or your server has it do at every time the machine turns on. And we'll see how it does. Let's take a look at software. Yeah, all right. So that was just a little automatic notification that went away. And this is pretty much it, guys. So you now have a Windows computer that you can use to do whatever you want out there on the internet, and we've talked about how to access it. So starting in the next videos, we're going to start setting this thing up. So for now, I'm just going to do what you should always do to any new machine, really, is just immediately restart it. It's going to break my connection. Watch. Computer's going to turn off. There goes my VM connection, because there's nothing to connect to anymore, and I'm back to that browser view that we started with. So that's it for this video. I will be seeing you in the next one when we begin to set things up.